There's this technology that sounds like it's straight out of a sci-fi movie, but it's real. We're talking about materials that can actually heal themselves. Think of them like having microscopic paramedics embedded in a surface, just waiting to rush in and fix damage the second it happens.
Ah, we've all been there, right? That horrible sinking feeling when you get the first scratch on your new car or your brand new phone. It's just the worst. But what if that scratch could just fade away? What if the surface could literally mend itself? Well, that's not a what if anymore.
So, what are we really talking about here? At its heart, these are super advanced materials designed to fix damage all by themselves. And honestly, the best way to think about it is your own body. You get a cut, and your skin just knows what to do, right? It heals. These coatings bring that same kind of biological magic to the things we use every day.
Now, this is about way more than just fixing a few annoying scratches. So, why is this such a big deal? Let's take a look at what it means to build a world that can actually heal itself.
This technology is a total game changer for a few really big reasons. For starters, it makes everything it's applied to way more durable and sustainable. It also gives incredible protection against the elements. I'm talking about stopping things like rust and corrosion in their tracks. And for you and me, that means we get to spend a lot less time and money on frustrating repairs and replacements. Okay, so how in the world does this actually work? Well, it turns out there are two main ways to make a material heal itself, and they both have a totally different strategy. Let's break them down. On one side, you have what's called the extrinsic method. Just think of it like we've embedded those tiny paramedics we talked about right into the material, waiting for an emergency. On the other side, you've got the intrinsic method. That one is all about the material's own chemistry. It has bonds that can break apart and then snap right back together, kind of like a zipper. Let's dive into each one. Okay, first up, the paramedic approach. It's actually a pretty straightforward four-step deal. First, millions of teeny tiny capsules filled with a healing liquid are mixed right into the coating. Second, a crack appears and pop. It breaks some of these capsules open. Third, the healing liquid inside immediately flows out and floods the crack. And finally, that liquid reacts, hardens up, and seals the damage like it was never there. And this diagram here shows you the whole process perfectly. You can see those little microcapsules just sitting there, waiting inside the material. Then a crack forms, breaking them open. Next, you see that blue healing agent just rush into the damaged area. And in that last frame, bam! It's solidified or polymerized, and the damage is completely sealed. It's a really elegant and totally automatic system. But, there's a trade-off with this paramedic approach. On the plus side, it's awesome for healing bigger cracks, and it just works. No trigger needed. But the big catch is that it's a one-shot deal. Once those little healing capsules in an area have been used up, that's it. That spot can't heal again. So if the paramedics are a single-use solution, what's the alternative? Well, that brings us to intrinsic healing, which is much more like a zipper. Here, when damage happens, it actually breaks the chemical bonds of the material itself. Then all it needs is a little nudge from something like heat or light. The polymer chains shift around, find each other again, and just zip the material right back together. This visual really shows you what's going on at the molecular level. On the left, everything's nicely ordered. Then, the damage creates a clean break, snapping those connections. But once you apply a little stimulus, those bonds reform, pulling the material back together and making it strong again. It is literally like zipping up a jacket. The huge advantage here is that it's reusable. Because it's the material's own chemistry doing all the work, it can heal over and over in the exact same spot. The downside, though, is that it usually isn't automatic. It often needs that external kickstart, like the heat from the sun or a UV light, to get the healing process going. So that's the cool science of it all. But this isn't just stuck in a lab somewhere. Let's look at some of the real-world ways this technology is already out there making a difference. One of the absolute biggest and most important uses is fighting corrosion. Just look at this diagram. As soon as a tiny crack forms in the coating on a piece of metal, these little microspheres inside burst open and instantly seal it up. That creates a brand new barrier that stops water and air from ever reaching the metal, and it stops destructive rust dead in its tracks. And this is absolutely crucial for our biggest and most important infrastructure. I mean, think about it. Coatings for giant ship hulls that are constantly battling salt water, oil and gas pipelines that stretch for thousands of miles, the bodies of aircraft, and of course, the massive steel bridges that we all depend on every single day. But hey, it's not just for giant machines. This tech is already making its way into our personal lives. Some car companies already use clear coats on their cars that can heal minor scratches using just the heat from the sun. And pretty soon, we're going to see way more durable self-healing screens for our phones, and even self-repairing paints for the walls in our homes. So where does this incredible technology go from here? Let's wrap up by looking at some of the current challenges and the super exciting road ahead. Right now, the main hurdles are things like high manufacturing costs, the fact that the capsule systems are single-use, and the need for a trigger for the intrinsic ones. But researchers are already tackling all of this. They're using nanotechnology to make healing more efficient, they're developing systems that can heal multiple times, and they're creating smarter materials inspired by biology that heal more like living tissue. And that leaves us with a pretty fascinating thought to end on. We are moving into an age where the things we build won't just break down and decay, they'll last, they'll adapt, they'll regenerate. So the question really is, if our world could truly mend itself, what would we choose to build to last forever?